Good evening everyone. In this video we will be talking about interaction modeling. The class model actually describes the objects in a system and their relationship. This we have discussed in detail. Okay, how different how different objects can be there in the system and what is the relationship between them. Okay, and then like let's say for example the classes are basically like the objects are okay, so they have this sort of identity, so which is like the class. Okay. So we have seen the class models in detail. So these class models actually describes the objects in the system and their relationship. Then we discuss the state model. The state model actually describes the life cycle of the objects. Okay, how the objects have will be in different states as the time progresses. Okay, so we have actually seen like the life cycles of these sort of objects. Then the third type of model in object-oriented design is this interaction model. The interaction model actually describes how the objects actually interact. So how these objects are actually interact to produce useful results. Okay, more or less like the simplest, in the simple way, like what it is like how the objects are actually interacting among themselves. Okay. So the objects, how they are interacting among themselves, how they are actually interacting with the system. Okay, so I will be discussing about all the things in detail. But to put all the three things together, the class model describes the objects in a system and their relationship. The state model describes the life cycle of the objects, and the interaction model describes how the objects actually interact. Okay. So to have a little bit more depth about what is an interaction model and how it is different from a state model, because like state model is also we are seeing how objects are in different states in it, so how they are actually changing across these states. The interaction model is a holistic view of the behavior across many objects. Okay, so interaction model is like say for example it is an upper view, okay, of the complete system. So it's a holistic view of the behavior across many objects. Whereas like a state model is a reductionist approach, okay, a reductionist view of behavior that examines each object individually. So basically like the interaction model is a view of the complete system, whereas like a state model is about observing each and every object individually. Okay, but of course like both models are needed to describe the behavior fully, and they perfectly complement each other. Okay, so by viewing the behavior of the system from two different perspectives. One is from the real at the low level, seeing at each and every object, and the interaction model looks at like how these objects are actually interacting among themselves. Okay. The interactions can be modeled at different levels of abstraction. Okay. So of course like abstraction is something like which is jumping always in this object-oriented design. Okay. So it is one of the very important principles in terms of object-oriented design. We have been discussing about these things. Okay. So the interaction models, like the interactions can be modeled at different levels of abstraction using different types of diagrams. Okay. At the highest level is this use cases. Okay. These use cases describe how a system actually interacts with outside actors. What these use cases, what these actors, and all the things like we'll be discussing in detail in the coming videos. But then like they actually describe like how the system actually interacts with outside actors. Okay. For example, like if there is a system which is like, say for example, it is about okay, so an ATM machine, or like say for example a machine which is giving some items. Okay, so its functionality is the basic functionality, how you basically deliver an item to the user. Okay, the user basically inserts the money and then like, okay, so it basically has to return the item. Okay, that's all one functionality of a system that is described by this use case. Okay, so it mainly focuses on the functionality that the system provides to its users. Use cases are helpful for capturing informal requirements. Okay. So that's how like we will document. Okay. So we will try to see like how they actually capture these sort of informal requirements, and then like ideal cases like how the functionality works and what will be the error conditions and all the things. We will be discussing about all the things, okay, about these use cases. So then comes the sequence diagrams. The sequence diagrams provide a little bit more information. Okay, so the use cases are at really high level. Okay, and sequence diagrams show a little bit more information, and they show like the messages that are actually exchanged among a set of objects over time. Okay, so how different objects are interacting and what are the messages which are actually exchanged across these objects over a time, time. So we'll be seeing like how it is actually put in the sequence diagram. Okay, of course in the coming videos. The messages which are actually exchanged across these objects can be both asynchronous signals and also like procedural calls. Asynchronous signals is like you basically send a signal and then like you don't care like when the response basically comes or else eventually it comes up. A procedural call is like a synchronous one, so basically you basically make the call to the particular object, it will do certain procedural call and sometimes it may return back. Okay. So they can be both synchronous and asynchronous. These sequence diagrams are actually good for showing the behavior sequences seen by the user of a system. How the user actually sees the system. So what is like how the behavior is changing. Okay, so this is about the sequence diagram. Then comes the a little bit level, more level of I mean like at the highest level of abstraction or use cases. So then comes the sequence diagrams. Then comes the activity diagrams. These show a little bit more information than the sequence diagram. They actually show the flow of control among the steps of a computation. Okay, so they can actually show both the data flows, how the data is actually moving around, and then like even the control flows as well. So they document to the level of to the level like the steps that are necessary to implement an operation. Okay, or some sort of business process. Okay, reference in a sequence diagram. Okay, so you have the sequence diagram, and then like these activity diagrams provide additional information. Okay, say for example, if a certain operation has to be implemented, so what are the steps which are to be taken care? So all these things are actually shown in sort of activity diagrams. Okay, so these three types of models, okay, so the use cases and the sequence diagrams and activity diagrams basically constitute this sort of interaction models. Okay, so regarding the reference concern, now we are in chapter 7 of this book. Okay. Thank you very much for your attention.